Hi there, welcome back to the channel. Welcome to the third video in the restoration of the Braun TS2. And this video is all about the AM bands. Long wave, medium wave and short wave. This radio has the three. I've got an issue with long wave. I'm getting absolutely nothing at all. I've got problems with capacitors that I wasn't expecting. So this is what it's all about. And I have got a new faceplate. But you'll have to watch to the end to see that. So I do hope you stick around and enjoy the video. But before we continue, I just want to thank the sponsors of the video, PCBWay. They're the guys that do all the PCBs for the projects that I show on this channel. The quality is amazing. The choices of materials, thicknesses, colors, and everything else is incredible. But the one thing I noticed recently is they've got an order status indicator, which is quite cool. This is my latest order, and I've always seen this here, but I didn't really know what it was. And obviously this one is completed, but it shows every single stage of the procedure. And if you want, you can actually click on here, and they've got videos showing what that procedure entails. And I've taken some screenshots of this particular order as it was in execution, and you can see that this was not 100% at the time. So whether you need the simple PCBs, or whether you want them to be assembled by them, which means they give it to you with all the components on it, or whether you're looking for CNC machining or 3D printing, go to PCBWay. I'm sure you'll find something for your needs. Well, I had a little surprise waiting for me when I was using this as an amplifier. Now, what I had, as you probably remember from the last video, is I'd set up just the audio, and I'd put on the Bluetooth, and everything was working fine. And there were no tubes back in the radio. So there were no EF89s, the two of them on the radio. There was no ECH81, there was no ECC85. So there were no tubes back here. And what I noticed while I was listening to this, I started seeing smoke from the underside, the top of the one of the IF cans, and I thought, geez, what the hell's going on? And it was sort of bubbling up, and I'd switch it off and it would go off and it would stop. And then I tried it again and I saw some more smoke coming up, so I turned it around like I have now, and this resistor was getting black, as you can probably see. This resistor was actually overheating, and this is odd because this resistor was actually feeding absolutely nothing due to the fact that the tube was out. Let me show you on the schematic. So this is the part that I was looking at. It's this first EF89, and this resistor here was the one that was overheating. So let's have a closer look at that. If we look at this over here, this is coming from B2 plus down here, and it goes through that 1K resistor. It meets a capacitor here. You can obviously see what the problem was, but I had no idea that that was the case. There's this little 50 picofarad capacitor and one winding of the first IF transformer. And then it goes to the anode of the EF89. Now, with this tube out, there was no path for current to flow. So when I looked at this, there were two possibilities. Either there was some sort of short in this winding, or this guy, well, even if this guy had shorted out, it wouldn't have been a problem. So the only option would be this capacitor. Now, this capacitor is one of the dog bones that I am repeatedly saying never go wrong. Well, they've gone wrong. See, this is it over here. This guy was not shorted. When I measured resistance, it was not shorted. But then when I removed it, I took the leg off there. It suddenly started working well. The voltage over here wasn't being brought down. I mean, at one point, the voltage there was down to about 90 volts. It's supposed to be 260 or something like that. So this capacitor was obviously the issue, and I replaced it, and now the problem is solved. Now, it's raised another issue, and that is that these dog bones, which, as I said, in my experience, very, very seldom go wrong. This one went seriously wrong. And the problem is there are a lot of them around here. You see there's one there, there's one there, there's one there, there's one there. And they're all these sort of 10-ish nanofarad capacitors, which worries me quite a bit. So I had a look at the schematic and I see these dog bones, and they're all 10 nanofarads, or most of them are. There's one, there's one, there's one. And again, this is a similar situation where this thing is getting the B plus or B2 plus through a resistor. In fact, it's the same value resistor as that one, 1K. It meets that. It's exactly the same, practically the same. And there's a 10 nanofarad. Now, this is my problem. I'm wondering if this is a batch issue, if all the capacitors of this batch had a problem, or whether that was one-off, because as you may recall, this thing actually broke when I removed it. So something was seriously wrong in here. But again, I start wondering whether I can trust any of them. And that's my quandary at the moment. I was considering just replacing them all, but then I thought, well, let me leave it for now. And I just made this note over here, suspect caps, and I pointed them all out. So if something goes wrong, the first place I'm going to look at is these capacitors, and maybe I will have to replace them all. I don't know. I hope not. I've got the capacitors, but that would turn this inside of the chassis to something that looks more like measles with all these yellow caps everywhere. So having resolved that issue, I want to test radio. So I'm going to turn this around. I'm going to put in the tubes for the AM bands, and that means the two EF89s and the ECH81. This thing has actually got a EF89 at the output of the FM. So that first EF89, in fact, that tube that on that circuit is not even used in the AM. But yeah, I'm a little bit uncomfortable at the moment. But let me try out the radio. Let's see if we get radio at all. There is one issue with the AM, and that is because, if you recall, there was a wire floating around here. One of these little wires seems to have been broken. So I think there's a circuit broken on the AM and on the ferrite antenna, which is part of the AM, and I think it only affects, yes, I know it only affects the medium wave and long wave. But anyway, I'm jumping ahead of myself. Let me put the tubes in and we'll test it, see what we're facing. Right, those two tubes are in. That's the ECH81 mixer oscillator. That's the IF amplifier. That EF89 over here, I'm not putting it in because I looked at the circuit. That's just an amplifier of the FM stage before it goes into the normal IF chain. So I think we're about ready. Now I'm going to put in the mini whip antenna into the AM antenna socket over here. And I'll put on the mini whip. And I know this is FM, shortwave. Let's try medium wave. And I've got the speaker connected to the external speaker sockets. Set the volume to max. And now I'm going to switch on the power. It's still on restriction, but I've got all the light bulbs in, so we've got very little restriction. See if we get anything. Let it warm up. Well, I can hear something, not much. Damn, that's really low. Ah, yeah. I'm picking up Canary Islands. All right, so medium wave works. Let's try F shortwave. This is very sensitive tuning. See at this end of the dial. Okay, it's all there. Now let me try long wave. Nothing. And that is more or less as I expected, because I think the little coil on the ferrite antenna that's busted. This selects ferrite when you're on medium wave and long wave, but that is busted, so I think we're losing the antenna signal through there. I'll have to look at the schematic and see if we can sort that out now. Well, that suspicion didn't go too well. This is the front end. I believed that for some reason the signal was not getting through to the front end because of that suspicious wiring, or that apparent broken wire on the ferrite antenna, which is over here. So what I did is I followed the antenna circuit, and you can see this, the pink line, that was all checked. Now this is for all the bands, remember, this is for AM bands, so shortwave, long wave and medium wave. We know that shortwave is working very well. And I've just got to say something. After listening to it again, it sounds like medium wave is a bit weak as well. which is a bit of a clue as to what might be going on. So anyway, here we go. We've got the antenna circuit comes through. This is the IF trap. It goes in here, comes down here, and we can see that the whole antenna signal is to the left, or to this side. It's galvanically isolated from this side, okay? So it comes through here, and this switch is that antenna switch that kicks in or cuts out the Farad antenna. And you can see that here, RU, we can see it's E123, there's E, and it's under the RU signal, so 1, 2, 3. So in one position, when it's not activated, 2 and 3 are shorted. So if it's not activated, it means we're using the external antenna, so 2 and 3 are shorted. So when that is made, it uses this circuit over here. Okay, when it is shorted, in other words, when it's activated, when you press RU, that signal coming from the antenna, see that? Goes through there, and it goes from 1 to 2, which means it's shorted to ground. So it doesn't use the antenna signal. So we are interested when 2 and 3 are made. In other words, when RU is not activated, when it's in its steady state, as it were, like here, okay? That was all fine. I found nothing wrong with that. So we go to the other side, and this starts getting interesting. This over here is a signal going to the grid of the ECH81 mix oscillator. So this is the output. This here, we can call that the output of the front end. So what happens here? Well, if we look at shortwave, when shortwave is selected, that's G. So we look down here, G, that is shortwave, 1, 2, 3. When it's not selected, 2 and 3 are shorted. So when it's not selected, when we're not choosing shortwave, we've got 2 and 3 made like this, okay? So that part of the circuit is completely ignored. This little section here is completely ignored. But let's look at it when it is selected. So 1 and 2 are made. Remember, this is the steady state. When you click it, it moves up. So 1 and 2 is selected, which means the signal now comes from here. So that is the shortwave. We know that's working perfectly well. Okay, so we ignore that and we go for the situation where you are not selecting K or shortwave. So it comes down here, and then this gets a little bit complicated because this is the switch, the C12345. C12345 is a long wave switch, and these actually run on top of each other, if you can understand that. So if we look at this, when we've got long wave not selected, in other words, when we select medium wave, this is the position the switches will be in. So 2 and 3 are made. 2 and 3 would be made. That's for medium wave. But because medium wave is okay, I've chosen to draw in what happens when we select long wave. So 1 and 2 are made. When we select long wave, this moves up. So 1 and 2 are made. That's what we've got here. So that goes like that. That there is from the ferrite antenna. I believe that's a ferrite antenna there, yeah. So that's a ferrite antenna. It goes through the ferrite antenna anyway, even when this is active. But the ferrite antenna will be the one receiving the signal and not that there anymore, because that would be out of circuit. So what we would have then is we would have this whole circuit is in line. So from ground, we've got the ferrite antenna, that trimmer capacitor, that coil, and it goes through there, and it goes down here, and it goes to that one, and all that goes to ground. And also, we've got this here. This one also moves up. So 1, 2, 3, 4, 5. So when we've got it selected, 4 and 5 are not shorted, so it's not shorted to ground. So 1, 2, 3 and 4 are made. So 3 and 4 are made like that. So that would go down here as well. That is for long wave. Now, all this seems fine. That little hair that we see sticking out of the ferrite antenna is a bit strange. It's a bit of the Litz wire that's sort of peeled off, but the continuity is there and the majority of the Litz wires are intact. So that is not the issue, which led me to look for the oscillator. Now the oscillator is a different story. That's over here. Now we know the oscillator works on some conditions, and the conditions that we know it works on are for shortwave. We know that shortwave works very well, and it's the same oscillator with different coils brought in and different capacitors brought in that is providing the the oscillator frequency for shortwave, long wave, and medium wave. Now, for shortwave, let's look at shortwave. We've got the standard thing, which is this thing over here, right? It's coming out here. It's biased with a 50K resistor. That's perfectly fine. Comes through here, comes through there, comes to there. Now, once it gets there, we've got G, 7, 8, and 9. Now G, 7, 8, and 9 is over here. When I click shortwave, 7 and 8 are made. So 7 and 8 are made. So from there to there is made, not like that. So when that from there to there is made, it means that the shortwave is being created by this inductor capacitor circuit. And everything else is out of circuit. All this is out of circuit, okay? So we know that that bit works perfectly well. Now, when we don't select shortwave, then 9 and 8 are made like that. There's 9, there's 8. So that's 9, there's 8. So that is shorted. So that goes down there and it goes to there. So what is the difference between long wave and medium wave? Well, strangely enough, it's only this switch over here. There's no more switching that goes on here. There's no switch here. But if we look at 7 and 8, F7 and F8, there's F, it's on medium wave. When you do select medium wave, it makes that connection. So when you do select medium wave, that gets shorted there, which means that this, and this is obviously to this point, so it means that everything in parallel with that is bypassed. So these components, that capacitor, that coil, and that capacitor are bypassed because this short brings it to here. So I figured, okay, it must be this here. But then I thought, you know, medium wave is not sounding that strong either. So if medium wave is not sounding that strong, maybe it's not these components down here. Maybe it's one of these up here. And let me go back to the radio and see if we can find something. Now, what could be wrong? We are receiving medium wave. It's not a question of not receiving it at all. We are receiving medium wave. It's just not that strong, which is a little bit strange because the shortwave is very, very strong. It's very powerful. I've checked that. So what could be wrong here? We could have a capacitor that's open here or something, but that would change the frequency. That wouldn't change the reception itself. Let's check the oscillations on the various bands. That's the first thing I'm going to do. Let's go back to the radio. Right, let's check for the oscillator signals, see if they're working. I've just made this little coil over here. It's literally a few turns of wire, shielded wire, and I've made it quite small because I want it to be focused on where I'm probing. Now I'm going to connect this to the end of my oscilloscope, just like that, nothing special. I've got it on shortwave. You can hear noise, but I'm going to probe along here to see whether I can find a signal somewhere, because I don't know where the shortwave coil is. Ah, there we go. See that? That is our shortwave oscillator. Change the range on the scope because I want to show you something. If I tune here, just turning the tuning condenser, that frequency is changing. And that's our shortwave. And what you'll notice is that if I move this, it actually adjusts the tuning. This little coil is actually loading that inductor, so it actually changes the frequency. So you can hear that. All right, that is important because it means our local oscillator for the shortwave is working perfectly fine. Now let me put it on medium wave. I can now read nothing there. And there it is. Let me change the scope range again. Just change the volts per division. Obviously it moves depending on how I hold this, but that is definitely the oscillator coil, the coil in the oscillator for the medium wave. And what I notice, again, if I move it, it affects the tuning because it affects the actual frequency due to the loading. But that's the one end of the scale, and then it does go pretty high on the other end. Change the scope range again. But as I said, this is still weak. Anyway, let's leave it there. And now let me go to long wave. I've got it on long wave. I get nothing there, nothing there, nothing there. By my logic, that should be short wave, medium wave, long wave, but there's nothing. Even if I change the range of the scope and I change the tuning, I get bugger all. making a noise at the end there, but it's not. It does not mean the oscillator is working. Something strange is going on here. Really strange. Let me see if it's anywhere else. No. This is actually affecting the tuning of it. This is strange. This must be the front end. Okay, so we know we've got oscillation on the short wave. We know we've got it on medium wave. We've got no oscillation on the long wave, which is the band that's completely deaf. So back to the drawing board, back to the schematic, see what's going on here. You might find this view a little bit strange because I've got the faceplate on. It's the one I'm not going to keep. This is the one I did on the transparency, the sticker transparency, but it doesn't really work well because I need a backing at the back. And I'm waiting for the UV printed one to come through. And listen to this. This is long wave. Now there's not much on long wave, but it's receiving. And the reason is because there was a broken wire, not the one that I thought on the ferrite antenna, but in fact one on the oscillator coil inside, which I'll show you in a minute. And it took me quite a while to find it because I was being rather stupid. So let me show you what it was and why I didn't see it right away. It was actually that little wire there from that coil to that point there where that 80K resistor connects. It was there, but it wasn't touching. And it was on this circuit, and the reason it was rather difficult to catch was because it's this coil over here. It's the oscillator adjustment coil for the long wave. You'll notice it doesn't have a trimmer capacitor like this one does. This has got the coil for the medium wave with the associated trimmer cap. That one has got the oscillator there, the coil with the associated trimmer cap. This one's just got the coil. And when I was measuring continuity, you know, I was measuring from there to there, getting nothing, and it made sense because there's a capacitor and I wasn't going to be bothered looking for that point, and I should have, because that's the guy that was loose. And it was very, very difficult to see. Very difficult to see. So yeah, that's my only excuse. So I've got it back, it's all working, but I've still noticed that the medium wave and in fact long wave is still fairly weak. And of course this wouldn't make any difference because on medium wave that is shorted there. So that wouldn't be the reason for a weaker medium wave. I think it's just the IF alignment that might be off for some reason, which also doesn't make sense because the short wave is going through the same IF chain. Anyway, when I do an alignment, I'll probably figure out what's wrong. Or maybe it isn't wrong. Maybe it's just a very weak medium wave section this thing's got. I don't know. Well, that's a relief. That one's done. Well, folks, look at that. My new faceplate has arrived and it is absolutely bloody beautiful. This thing came out so much better than I expected. Really, so much better than I expected. And what it is, it's a sheet of acrylic, 3mm acrylic, and it's printed on the reverse, so there's nothing on the front, on the reverse with a UV printer, something which I hadn't tried before. Actually, I didn't do it, I had them do it for me. And then they've printed a backing cover, a white backing cover, on top of all the text as well. So they've printed the backing twice, really, just to protect it. And it's come out fantastically. Now this is all grayscale. Strangely enough, I tried with the blue, and then when they did a sample print over there, it didn't really work that well. So before the white is printed on the back, this thing is like a 40% gray, and then they print the white on the back because you wouldn't see it otherwise. It would just be as transparent as that film one that I showed you before. So this is now, oh, I love it. I love it. And everything actually worked out very well. All the gaps are visible. The windows for the tone level is visible. The magic eye hole is there. Everything is so really perfect. There was one thing they did warn me about, and that was fine. The biggest they could print was 50.6, no, 51 centimeters. This thing is 52. So there's a little gap of, I think there's 6 millimeters on the end where it couldn't reach. And they asked me if that was okay. And I said yes, because this thing gets this rubber band over here, which holds it in place anyway. And the same applied to that side, but you can't see it, obviously. But what really amazed me is that you can see that the point is perfectly. There's no shadow, there's no double layer like I did with the previous one. I did it was like a vinyl cutout sandwiched between two acrylic sheets. And this thing, I love it. And you know what? The fact that it's acrylic is fine, because all the keys and the knobs are already in a plastic. So this is actually quite, you know, in line with what Braun was doing at the time. And the fact that it is the modern look, and this is what it did look like, the fact that it is sort of a modern, yeah, more modern look, it's perfect. It doesn't detract from it at all. In fact, it adds to it. I'm so pleased with this. I really am. There's one little problem. One little problem. This thing cost me almost 40 bucks to have done. Now, various reasons. One, it's a professional service. Two, it's a professional UV printer, and I've seen what those things can cost. And three, you know, a one-off. I go to one of those print businesses and ask them for one of these, and they really have to stop other stuff. And they did, yeah, they took about a week, but it's not exactly the sort of thing they geared up for. So I guess I'm thankful for it. And I also saw what the price of some of these UV printers is. So yeah, my wife doesn't have to worry. I'm not going to be getting one. They can be very expensive. The good ones can be really, really expensive, and they are big. So I don't have the space for it anyway. So I'm sure that I'll be using their services again. The biggest challenge is drawing the faceplate, and I didn't scan the old one. You could do that, try and scan the old one and correct the text and all that. I actually drew this item by item, element by element in an Illustrator equivalent software. So it's a vectorial drawing, which then gets exported to high quality PDF, and I gave them the PDF. And obviously you do this on paper first in wireframe to make sure that it actually fits, that all the holes correspond. I showed you that previously, before you get them to do the final one. But if you take your time, it's done. And just so that you know, this faceplate art is available for anybody who wants it. If you need it, just send me an email and I'll send you the files. I'll send you the Illustrator type file, the vector file, as well as the PDF, because you might want to tweak the colors a bit. It's up to you. But it comes out fantastically, and when you switch it off, it looks exactly the way it did before. It's amazing, amazing. Yeah, right, I'm happy. I'm happy. In fact, I'm so happy I'm going to leave you now. Right, I'll tell you why I'm leaving you. I needed the faceplate because I needed to check the alignment on this thing. And the reason is that I did tweak quite a few of those coils and trimmers at the bottom, trying to get the oscillator to work when I didn't know that one of the wires was loose. The difficulty here is that I couldn't find an actual instruction, alignment instruction set for this particular model. This is the RC61. The one I've got is for the RC62, I think, which is for the Atelier. And it is different, and also it's very dark. The picture they've got there indicating where the coils and the trimming points are is very dark, and I can't really see what it's pointing to. So I have to sort of turn this upside down, and I've got to sort of try and figure out exactly what these guys are. Now, I do know that this one, and this one, these three are the oscillator coils for the shortwave, medium wave, and long wave. I know that. Now, there are a few other things here. I know, for example, this is the trimmer cap for the shortwave. This one, I think is the trimmer cap for the medium wave. I know that this one doesn't have a trimmer cap, but then I see these guys over here, and I know some of these are the front end tuning. So for shortwave, medium wave, I don't know if long wave one is adjustable. On the Atelier, there's a couple more of these over here and there. So even though it's pointing to all those, I can't even see the picture. So what I'm going to be doing is checking the circuit again and doing a photo of this and actually indicating what these are. The other thing is they tell you the alignment points, like they call this A, B, C or something. They don't tell you that this is coil 21 and this is trimmer C50 or whatever. And I want to be able to provide that. And leave it on record, so if anybody wants to align one of these in the future, they know exactly what they're aligning at each stage. That, of course, I'm talking about the RF alignment. And with that, I'm off to enjoy some sunshine. I do hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Thanks for watching. Bye for now, and most of all, stay safe.